Hello friends. So till the previous video, we have seen that how to calculate the effect of voltage perturbation or voltage fluctuation at the supply, and with respect to that fluctuation, we have to calculate the voltage and we have to see the effect of this fluctuation. Okay. So regarding to that particular concept, we discussed the video we have calculated directly by approaching this closed loop concept there. Or I mean to say, we have considered whatever the component is there, and by considering all the node voltages, we have calculated the final response, output to input. So we have calculated what we have calculated, V out by VSS. This is the gain from supply to output. Okay, so this thing should be as minimum as possible because we don't want any particular fluctuation to come at the output. So the same concept I have analyzed in the different way also. We can consider this particular thing in the way where we are considering a negative feedback system. Okay. So this thing we already seen how to introduce the negative feedback concept in our discussion. So what is happening here? So this is nothing but a feedback circuit. My amplifier is nothing but coming in the feedback. So what we can see, because we are applying the input, not we are applying, but yes, this is the fluctuation that we have on the VDD. So it will work as the input for me and output is here. Okay, so this is the input and this is the output. And what we can draw the amplifier in this feedback fashion so that we can analyze with the feedback concept. Okay, same is happening for the second circuit. Again, we are applying the input or we are seeing the fluctuation that is considering as an input at the VDD that we are shown here as a VSS, and we are observing the output here. Okay, so again, we can consider this amplifier in the feedback fashion like this. Okay, so we will analyze the circuits one by one. What we will do, the procedure will be simple. When we means analyze the circuit with the negative feedback fashion, then what we do? First, we will see total open loop gain. Second, we will see feedback factor, and third, we will see what is your closed loop gain. That simply comes as open loop gain. If I am talking about the DC fashion or DC gain, then it is AOL. Okay, so these are the three steps we have to follow. So let's draw the one by one circuit and we'll see how to calculate this. Okay, so if I'm considering the first circuit first, so what is the circuit? Okay, so this terminal is negative and we have seen because positive terminal is at input voltage, and when we are considering the input as a VDD fluctuation, then this input should be shorted. Okay, so this input should be shorted. Okay, so means positive terminal is shorted here and negative terminal is nothing but your coming from the output itself. Okay, so we are taking output here. This is my nothing but an input, what I call supply input, small signal perturbation. Okay, so if I want to see the gain directly we can calculate, but what I want to see here, I'm using the negative feedback concept. So first we will break the loop here. Okay. When we break the loop here, we'll apply some sort of source voltage here and some source of some sort of feedback voltage we'll observe here. Okay. So this way we can analyze in the way, because both the nodes are high impedance node. Whether there is a input of means what I say transistor or it is an input of your amp. So we can break the loop anywhere. But I want to consider my amplifier in this feedback means a factor. Okay, because I want to consider my amplifier, this is my amp, and I want to consider it in the beta factor. Okay, that's why I have taken the I broken the loop here. You can break the loop here also, but in that sense what will happen, your again the negative feedback will remain 1 rather than okay, beta will remain 1. So by breaking here, we can take this amplifier in the beta factor itself. Okay. So what the resultant diagram will have, this is the input. Now this will be ground because I am applying here the source voltage. That is some means excitation I am applying here, and I want to observe the feedback voltage. Okay. So it is ground. So what we can see, this is my V out, and here we have some resistor R. Okay, so this is the feedback voltage. So what is the beta? Beta is nothing but V feedback by V out. So it simply comes as, if I want to see here, V out is it. So what is VF? VF is nothing but A times minus V out. Okay. So what is the VF by V out? VF by V out comes as minus A. Okay. That we can put here. This is by beta. Beta is nothing but minus A. Okay. So what is the feed forward gain that you want to see from feed forward gain that I want to say AOL here, or I should say AOL dash, because AOL my complete loop gain that I want to see from, including the beta factor. Okay. So wait, yeah, beta factor is separate, and we want to see the gain from VS to V out. So what it will be? Let me calculate it. So it is from V out to VS only. This is my AOL dash gain. Okay. So when we will be considering my closed loop gain, that is a complete closed loop gain, what it will be? It's AOL dash divided by 1 plus beta times AOL dash. Okay, so this will be my closed loop gain for the entire system. Nothing but it is what V out by what is there. Okay, so what it should be V out by V. Okay, so what we are seeing here. Okay, what is the V in here? V in is nothing but a VSS. V out by VSS. Okay. Hmm. So we have seen the feedback factor, or VS is not as such mandatory here, because VS is only required when we calculate the loop gain. But yes, we can use the loop gain also to calculate the closed loop function or closed loop gain. That is not a problem. And what directly closed loop system gain is what? A closed loop we can also use 1 upon beta by loop gain divided by 1 plus loop gain. This is also a valid way of calculation the closed loop gain. Okay, so again I am not going to tell means all the calculation in detail. Just the point was here to tell you whether we can use this negative feedback concept here, and if I am using the open loop gain, that is simply the gain of this transistor, that is the open loop gain I'm using here, and a feedback factor I'm considering my amplifier. So is it a correct way of calculation? And just calculate and match your answers. Okay, and if I'm taking a second circuit, okay, if I will do all the calculation in detail, then it will again take a time and lengthy video I don't want to form. I just want to give you the way where you can analyze a circuit in different fashion. Okay, so what is the other circuit? This is my other circuit. Okay, so here is my amplifier. Okay, so this is positive, this is negative. Okay, so just you have to see what you have to again break the loop here, and you have analyze the circuit. Okay, so if we break the loop here, we are applying a source voltage here, we are observing the feedback here, we can calculate the loop gain, one thing. Okay, so we can calculate the loop gain, or we can calculate, also we can calculate the beta. Third thing, also you can calculate the open loop gain, which is dash here, where I want to see from means input to, this is my input, I want to see gain from input to output. This is my nothing but AOL dash. Okay, and beta is nothing but beta is a function of the amplifier gain. Okay, so from these three things we can calculate the gain. So what is the way? One way is that we have seen it many times in the frequency domain analysis. One way is directly calculating the AOL divided by 1 plus beta AOL dash. This is one way. When we have this gain from VSS to V out is the AOL dash. What is the AOL dash? AOL dash is nothing but V out to VSS, and beta is from V out to V out to V feedback voltage, or I should say feedback voltage by V out. So one thing we have to see whether it is properly working as a feedback or not. This thing we have to observe and accordingly proceed for the calculations. Okay. So this is the one other way. And the third thing we can use loop gain also here. I told you first. What is the loop gain? Loop gain is nothing but what you are seeing AOL dash, which is nothing but from VSS to V out and times beta. Okay, this is the loop gain. And other way of calculating loop gain is if we have this VS, this is a VF. We have seen it many times. Then VS by VF equal to loop gain. Usually we write like this. Okay, then what we can see here, we can write a closed loop function in two ways, which is nothing but a closed loop function. One way this AOL dash by 1 plus beta AOL dash. Other way is this 1 upon beta is common. If I have loop gain, then I can use the loop gain 1 plus loop gain. Okay, this way we can use these two things we can use to calculate the DC closed loop gain. Okay, so my way of telling that what I want to see here is I want to see the effect of the negative feedback system. I will not go into the depth calculations here because this thing you have to do by your own. The point was here to tell, the point here was to make you aware of this looking at the negative feedback system. Okay, so the point here was to look at negative feedback system. Look at the concept of negative feedback system. Okay, so this circuit can be solved in many ways. Just I want to make you clear one thing, that how we can analyze the circuit in different ways. So we must have the understanding. Many other things can be discussed in this particular video itself that I'm not uh, discussing here. What I can do, I can drive my capacitive load also. I can reduce the value of this resistor and many more things what we can do if my this entire system is uh, driving some other circuit, then that circuit can offer various capacitances also. What we can do, that we can model as a C. And other thing that we can see, because whatever my this amplifier block is nothing but a 5 transistor OTA structure LED I am considering. Then I can consider here cap also. Okay, here also I can consider the capacitors. And if you want to see, let I say, this is CP, this is parasitic capacitance. And what you can see, you can use these things in your calculation and you can analyze the same CTQ problem in various ways. If I'll all take in my videos, then maybe the one CTQ can end in a 5-6 videos. Okay, and itself, this CTQ 11 is going to be the fifth video. Okay, so these are the ways where you can analyze your circuits in various ways. Okay, so this amplifier is not that ideal block. It is nothing but designed by some 5 transistor OTA blocks, or maybe it is designed by some a two-stage op amps, maybe the folded cascade or telescopic structure. So depending on this, you can consider whatever you want to put inside this amplifier block, that is a A. And with that particular sense, we can also analyze the frequency domain calculation for this circuit. Because till now, whatever we have written, we have only written the equation of B out by B in wherever required, only at the DC. But you can also write these all things closed loop transfer function with respect to the frequency. Then here, whatever the open loop transfer function we will use will be this. beta times your EOLS. Okay, so it depends whatever you want to see and how we want to see the calculations. If we are considering the capacitors, then we have to involve all these terms, and then our transfer function will result into the function domain of the S. Okay, and also we can write this closed loop transfer function in the OS domain with respect to the loop gain also, and the loop gain also the function of frequency. So it depends on our vision how we can see the circuit and how can analyze. So many more things are remained in. You can modify the circuit and you can analyze in your way. Okay. So this is enough for this video. Thank you.